So going back to our example, talking about kings and queens and a deck of cards, the probability of the queen happening was 4 out of 52, or 1 out of 13 for reasons we've discussed earlier, as we have 4 queens out of the deck of 52 cards, or 1 out of whichever suit they end up in. If you keep the queen, then the likelihood of your next draw being really anything else, not just a king, but whatever card is in there, will be affected, because you've taken 1 card out of the deck already. So, for the king in particular, we still have 4, but now out of 51 remaining cards. And to be a bit more specific, a bit more clean with our notation, we could refer to something like that in terms of conditional probability as the probability of whatever B is given A using that vertical bar. So, if you want to talk about those cards from earlier, you want to talk about what happens with the probability of king given queen, we could write it like so. Probability of K given Q, that vertical bar there again means given, was specifically the value 4 out of 51, or approximately 0.078. That is about 8%. Where it's important to understand here that when we're looking for that conditioned part, it is an important component of what goes into the multiplication rule for dependent events, but sometimes we do want to specifically look at what happens just for the part of the thing affected by a different choice. Sometimes it's a thing that we're particularly interested in, as especially in the context of contingency table options, which is what we're going to finish this chapter off by looking at an example of. The table shows the results of a survey in which 2,276 social media users were asked whether they have ever been offended by something they saw on social media. Find the probability that a user is male given that the user was offended by something that they saw. So, the problem here is to really just carefully read the table. We can start with the assumption that the user is offended, which means that despite all the things that are in the table we're given here, really all that we care about is the first column, because the first column is the answer of yes. We only really care about offended people in this context, and thank God someone is concerned about their feelings if they were offended. Sorry, that's a little bit inconsiderate, but, well, you know. Anyway, for this, if you want to find the probability that a user is male given that they were offended, well, we go into that column. We see that there were 1,151 offended people, and of those offended, 532 of them were male. So this is our probability, where if we want to be a little bit more decimal flavored here, we could write that as 0.0462. That is about 46% chance, given the data we have here, where it's important to understand that if we rephrase that, we could talk about the probability of getting someone who is male regardless of whether or not they are offended, which would be the full 1106 men out of the 2276. That is the entire second row. Or we could talk about all the people who were offended, which would be 1151 out of 2276. Or we could talk about the people who were offended given that they were male, which would still be that 532, but instead of being out of the 1151, we'd be focusing on the second column, so that would be out of the 1108, which is, again, a whole bunch of different ways that this thing can go, a whole bunch of different problems we can run into here, so just be very careful about reading the table. The actual number is not going to be very hard to find, you just have to make sure you're looking in the right place. Anyway, that's all we've got here for chapter 11. So let's jump in to our last chapter with a look at stats. See you all again.